Alrighty, hello everyone, and welcome to our Lowell Observatory Interactive Stargazing and Mars Opposition Night. My name is Claire, and I'll be talking to you guys today. I'm an educator at Lowell Observatory, and if this is your first time joining us, I'm just going to walk you through a little bit about how we're going to do tonight. So the first part of the night is we're going to be doing our interactive stargazing. So if you're unfamiliar with that, I'll be showing you guys some pretty cool objects using our plane wave Cam telescope up at our Giovanni Open Deck Observatory. And so if you have any requests for objects that you'd like for us to try and see, please put them in the chat and we'll try and pull those up for you. And then the second half of the live stream, we'll be talking about the Mars opposition, and we'll have a couple guest speakers that will be able to talk in detail about that. So that will kind of be the showcase for the second half of the night. So to start off the night, we have just an image of Mars. So right now, Mars is pretty low to the horizon. We're also looking through quite a bit of atmosphere, which is why the image looks a little bit fuzzy. So we aren't stacking images right now. This is a live view of Mars. So that's why it may look unfamiliar to some of these more crisp images that you see. But we'll have some pretty great views later on in the evening. So to kind of start off the night, I'm going to talk a little bit about galaxies. So the first thing we're going to look at before we move to some of the requests is going to be the Andromeda Galaxy. So we're going to pull that up here. So what you see in front of you is our plane wave software. This is how we control the telescope. Super easy. We just point and click and it'll move itself for us. So we have moved to the Andromeda Galaxy and we'll be able to pull up an image pretty soon. So what even is a galaxy in the first place? So a galaxy is a giant collection of gas, dust, and stars that are all held together by gravity. Galaxies can have up to 1 trillion stars in them, and most of them have supermassive black holes at their center. So while we start to pull up the image of the Andromeda Galaxy, let me just tell you a little bit about the Andromeda itself. That's a great image. So the Andromeda arrives in our fall skies, so it's kind of one of the objects that we look for as the fall seasons come around. And it is the most distant object that you can see with your naked eye. So the Andromeda is a spiral galaxy like ours, and it has that nice bright central bulge that you can see in the center. So that really, really bright area in the very center of this image is where most of the stars are in this galaxy right here. But kind of a little bit right in front of it, you'll be able to see this darker area, which are signifying some of the spiral arms of the galaxy. So that's a lot of the dust that we can see, and that's where a lot of the star formation is happening right now. So the Andromeda has, we think, up to about 1 trillion stars, and a little bit about the history of observing this object. The earliest recording observation that we have found was around 964 AD by some Persian sky watchers or night watchers. And one of the first telescopic observation was by German astronomer Simon Marius. That was just a couple years after Galileo kind of made the forefront of looking at objects in the night sky with telescopes. So that was just a couple years after that whole idea came into being with Galileo. But a really important part of history of Lowell Observatory and with the Andromeda Galaxy is one of our astronomers, Besto Sliper, made an observation of the Andromeda, or M31, with his ongoing radial velocity research. So for those of you who are unfamiliar with what radial velocity is, it is simply the speed of an object along the sight between the object and the observer. So he was doing this research and he found that the Andromeda had a really, really high radial velocity for what we have observed for the time. So we observed it to be around 670,000 miles an hour that it was moving, which is one of the fastest recorded objects that we have had at that time. And we now know that the Andromeda is moving quite a lot faster, but Slipo's work was some of the most well-cited and some of the forefront in the discovery of the expansion of the universe. So many of you guys have probably heard of the theory of the expansion of the universe that was put out by Edwin Hubble. So Edwin Hubble actually used some of the data that Besto Sliper took with Andromeda and some of these other galaxies and radial velocities to come up with that theory. So we had a pretty big job in kind of starting that, and that's kind of a cool tidbit of history with Lowell Observatory and with the Andromeda Galaxy itself. But another kind of cool fact is that the Andromeda and the Milky Way galaxy are slowly moving towards each other. Well, not exactly slowly, but in our sense of time, it is moving kind of slowly. So we think in about 4 billion years, the Andromeda and the Milky Way galaxy will collide into one giant galaxy. So we think we're going to call this like the Milkdromeda, something like that. It'll definitely be an interesting name, but eventually in about 4 billion years, these two galaxies will collide. Now you may be wondering what will happen when these two galaxies collide. Really, most of the interaction that's going to happen is between our central black hole and the central black hole of the Andromeda Galaxy, but because space is so vast and there's still so much space between stars within a galaxy, no stars will actually collide. There won't be like star smashing or planets smashing together just because there's so much space in these galaxies. So let's go ahead and move to some of the requests. So a little bit earlier, I see that we had a request to see some of the moons of Mars. So right now, we can't see them because they are too small to be able to observe right now. So we won't be able to get the moons of Mars tonight. We have another question from William Bailey. Is the age of Andromeda similar to our galaxy? I think we think the age of Andromeda is around 10 billion years old. I think that's an estimate. I'm not entirely sure how that compares to our own Milky Way, but that's I think what the age of the Andromeda is. We have another request from Zach Davis. Is the Christmas tree cluster visible? So the Christmas tree cluster is not currently up right now. So we won't be able to view that tonight, but we might be able to get it in one of our later talks if you keep tuning into these. So if there's not any requests for the moment, let's go ahead and move to the Dumbbell Nebula. So this object is going to be quite different from the galaxy that we just saw, M31 or Andromeda. So the Dumbbell Nebula is what we call a planetary nebula. Now, when we say planetary nebula, you might think that it has something to do with planets. The name is actually really misleading to what the object really is. It has nothing to do with planets. So as we grab this image, you might see these streaks across where we are looking. That is just because we haven't stopped taking a photo while the telescope is moving itself, so it'll kind of smear the stars. All right, so here's the Dumbbell Nebula. As you can see, it's a really gorgeous object to look at. It's one of my favorites. I think it's also known as the apple core nebula. It kind of gives that shape of an apple core that has been pretty well eaten. But these planetary nebulas are the remnants of dead stars. So stars that are about the mass of our sun, so not big enough to supernova, will eventually end up something like this. So once a star like our sun burns up all of its fuel, it has no fuel left to burn in its nuclear fusion at the center of the star, it will become rather unstable and it will kind of just like loosely push this gas out into this circular-like object. And that's kind of what we can see happening here. So at the very center of this nebula, there's going to be a white dwarf. And that white dwarf is the dead core of that star. And then we have all of that gas that used to be that star that is slowly spreading out and around it. Now, the really cool things I think about planetary nebulas is the color that they give off. So as you can see kind of around the edges, there's a little bit of a rosy red color. That's going to be an indication that this is a lot of our hydrogen and helium gas. Towards the center, we're going to have more of our carbon and nitrogen. So by looking at the colors of these gases and using our knowledge of spectroscopy, we can actually figure out what that star was burning through during its lifetime and what it was made out of, which is pretty cool. So it looks like we have a couple more requests. So are there any binary stars visible to the naked eye? So yes, the binary star Mycor and Alzar in the Big Dipper or Ursa Major is two pretty good eyes visible to the naked eye. I believe it used to be an eye test. So if you could see both of those binary stars, you had pretty good eyes and you could pass that eye test, but I was never able to do that. So that one is, if you have pretty good eyes, supposed to be visible to the naked eye. So it looks like we have another one is the Cat's Eye Nebula. I think someone asked for the Eye Nebula. I think you might be referring to the Cat's Eye. So our Cat's Eye Nebula is behind the building, so our telescope unfortunately can't reach in that area. But we can move to another nebula for the time being. So let's go ahead and move to the Trypan Nebula. So this one is going to be different from a planetary nebula. It's going to be a star formation region, and it's going to be pretty close to the center of our galaxy. It's in that area. It's around the Sagittarius constellation area. And this object is also one of my favorites to look at. So when we say star formation region, it can also be called a stellar nursery nebula. It is what it sounds like. So it is basically where stars are born in the night sky. So this is a bunch of hydrogen gas that is slowly being manufactured into new baby stars. So this nebula is really cool because there's actually 3 parts to this nebula. So you can see 2 distinct colors and then a really dark, like wispy spiderweb type looking thing in the center of that red one. So there's a couple different types of nebulas here. We're creating some nice shadows, but this is one of the prettiest star formation regions I believe there is to look at. Just because it has some great color and we can see some of that shadow of the gas, which kind of gives the illusion of the 3D parts of this type of nebula, which is pretty cool to look at. So that's one of the prettiest ones to look at. We have another question. How far apart are the red parts of the Dumbbell Nebula? I don't know exactly off the top of my head, but I'm assuming they're going to be between 1 and 2 light years across from each other. 3 light years, I think that's what just came in. So about 3 light years across from each other. So it's a pretty sizable planetary nebula. Okay, another request, can we see the Helix Nebula? Yes, let's go ahead and head to that. So forewarning, the Helix Nebula is going to be a little bit dim, and it is a pretty dim nebula. So we'll do our best to be able to try and see this. It might take a little bit of a longer exposure, but we'll be able to get hopefully something in there. So while we wait for that, the Helix Nebula is a pretty interesting one. It is also one of the most famously imaged nebulas out there. So there we go. We're starting to see it kind of in the center. Again, it's a little bit faint, so the colors aren't going to be extremely stark to us as some of these other nebula, but we can start to see that nice red color around the edges, a little bit more of like a bluish green color in the center, and I think that is a white dwarf at the very center of this nebula right in there. So this one's kind of similar to our previous planetary nebulas like that. But this one's a little low to the sky, so we're looking through quite a lot of air and horizon right now. But it is a little bit faint, but we can still see some of those colors. So let's go ahead and move to some others. Let's see. We have a request for M15. M15 is good, so we're going to go ahead and move over there. So M15 is going to be a globular cluster. So this one's just off of the head of Pegasus, the constellation. So M15 is one of the biggest and brightest globular clusters that we have in the sky, and it is by far my absolute favorite to look at. So I'm really excited that someone picked this one out. M15 has about 500,000 stars in it. It is about 32,000 light years away, so it's a pretty sizable distance. And we're pretty sure that M15 actually has a central black hole that is keeping all of these stars together. So the name globular cluster, perhaps you may be unfamiliar with what this is. A globular cluster is a dense cluster of stars, usually around hundreds of thousands of stars that are all bound by gravity. So they're in this big gravitational system. I kind of describe them as like one big happy family of stars that can't ever escape the household because they're bound by gravity. So there's no chance of them really leaving. And again, this one is one of the biggest ones that we have. There's a central black hole, which is kind of cool. But they're amazing to look at. They're really pretty. I think it kind of looks like a frozen firework, or perhaps like glitter being dusted onto like black paper, or powdered sugar being dusted onto an eyepiece. They're just really pretty and very sparkly, and they're really awesome to look at. So we have another request for NGC 300. So NGC 300 is too low for us to be able to image right now. Maybe we can resolve some binaries in Lyra. Oh, we can't. Okay, so I'm looking at the chat right now. So let's go ahead and move to Alberio. That's another request that we have, which is also a binary. So that one is just in the center of the summer triangle, which is starting to set right now as we are moving into the autumn months. But we're going in and around here. So the Albireo is a binary star system, we are pretty sure. So there's two ways that a binary star system can go. They can be spectroscopic, or they can actually be binaries. So spectroscopic means that they look like they're binary stars, but we don't actually know because it's very hard for us to tell. And then actual binary star systems are where the two stars are orbiting each other. So we're not entirely perfect in terms of what this one is, but Albireo is still beautiful to look at because it is two very different stars close to each other, and they can kind of showcase how stars are different in the night sky. So we have at the center one, the big red one, that's our big red star, and then we have a smaller one up to the right that is going to be kind of more of a blue color. So the red star is going to be older and colder than that blue star, which is going to be a lot hotter and younger. So the colors of stars can kind of allude to their temperature. So again, red is cold and blue is hot, which kind of is contrary to what we might think in the first place. But Albireo is a really great object to look at just to kind of showcase that difference, because sometimes stars can kind of look the same in the night sky, but in fact, they are all different colors and sizes and temperatures, which is really cool. So we have some other objects coming in. So we have a request for the Veil Nebula. The Veil should be good, so we're going to go ahead and move to there. Alrighty, so the Veil Nebula is different than all of the nebulas we've already looked at. So the Veil Nebula is going to be a supernova remnant nebula. So that means that this is the remnant of a star that has supernovaed or blown up because it was massive enough to do so, and this is kind of some of the gas that is left over. So this one is a pretty faint nebula to look at, so it'll take us just a bit to pull up that image, but it is, this is a great image. This is so beautiful. So as we can see, it's very elongated. It is stretching across most of our field of view, and we can see those amazing colors of blues, greens, purples, and reds, and kind of those rosy colors. So this is just a really amazing one to look at. It is incredibly detailed in terms of the structure of gas that has come about after this supernova, and it's pretty amazing to look at. This is definitely one of my favorite nebulas as well. It's so beautiful. So that was a great request. Let's see. So we have another request for the Crab Nebula. So the Crab is too low right now. And it looks like we also have a question. So what does Mars look like outside during the opposition? Sky is clear in my neighborhood. So Mars will be basically its biggest and brightest at this point in time until the next 15 years. So it is super bright right now. It's not going to be as bright as a full moon, but that's kind of a misinformation on that end, but it's going to look like a pretty big and pretty bright, like red glowing thing in the sky. So that's what it should look like. It should be pretty apparent which one is Mars because it will be slightly red, and it will be one of the brightest things in the sky at that time. And you will be able to see Mars basically everywhere where you are. Even if you're in a city or anything like that, you'll be able to see Mars. If you go outside and look towards the east, it'll be right over there. All right. So let's go ahead and move to the Eagle Nebula. So I think that's next in line for requests. So the Eagle Nebula is going to be another star formation region that is pretty close to the constellation Sagittarius. So the Eagle Nebula is definitely one of my favorites to look at. So once we pull that up, so the Eagle Nebula also has what we call the pillars of creation within them. So you might have heard that term. The pillars of creation are one of the most famous Hubble images ever to be imaged. If you go ahead and do a quick Google search, you will definitely most likely recognize the pillars of creation image that we can see. So we can see them kind of to the left of the image right here. They kind of look like stacks of gas coming up and creating shadow behind that nice rosy colored gas in the background. Yeah, so we're zooming in right there. Those are the pillars of creation. So this is a giant cloud of hydrogen gas that is also manufacturing stars that we can see. So This is a star formation region. Stars are forming in this region all the time, and it is definitely one of the prettiest ones to look at. Just the detail of this specific nebula is really cool to be able to see. I really like the shadows on nebulas. That's kind of one of my favorite things to look at. So we're getting a lot of requests, so I'm going to go ahead and move on. We're going to move back briefly to Mars, just so some of you guys who may have just joined can get a brief look. But again, we'll be focusing more on Mars for the second half of our live stream, so we'll be having a couple guest speakers that are talking about it at length, and we'll have an image through our historic Clark telescope around 8:30, starting with that. So hold on for that too. We'll be looking at many images of Mars. So Mars will definitely be in demand tonight. So we're changing some of the settings. So obviously Mars is one of the brightest things to look at right now. So we've changed to video mode, meaning we're looking at a live image right now, and we're lowering our exposure to make it less sensitive to so much light coming off from this planet in the sky. So again, we're looking through quite a lot of atmosphere, and we're pretty low to the horizon for Mars, so it's going to look a little fuzzy to us. And again, this is also a live image, so we are currently not stacking these images so they won't look as clear as some of these more edited ones. This is a very live image for us to look at. Alrighty, so let me go up with some of these others. Let's see. We have a request for Saturn, so let's go ahead and move there to another planet. So Saturn is our second gas giant planet after Jupiter, and it is most famous for its rings. And Saturn actually also has the most moons out of any planet in the solar system. So it has 82 moons compared to Jupiter, which only has 79. Still an amazing amount of moons, and I'm sure we'll probably find more as we learned to better explore these planets. But we can get a really nice view of the rings right here in front of us. We can start to see some of the detail on Saturn itself as well. Saturn is just an amazing planet to look at, by far my favorite to look at as well. So that's a really nice view of Saturn. Again, this is a live image too, so it will look a little wobbly and not quite as clear as some of these more edited photos, but the rings are coming out beautifully tonight, so I think that's a great one to look at. So we have another request for Neptune with Triton. I think we should be able to at least get Neptune, hopefully. Let's see. We have lots of requests tonight, which is awesome. I'm so excited to see all of you guys wanting to see so many things. Just a forewarning that we will have to move on to our Mars opposition live stream segment at around 8:30. So if I don't happen to get to your request tonight, no worries. We'll have another live stream next week where you can request the same thing, and hopefully we'll be able to get you in there as well. So might be a good time to subscribe to the Low Observatory channel just in case, so you don't want to miss that live stream in case you definitely wanted to see your object and we don't have time to get to it tonight. So I'm not sure if we'll be able to pick out Triton in specific. It might be too small for us to get right now, but we can definitely see Neptune. So you can see that it's nice, bright and blue. That blue color is just really amazing to see. Neptune is the last planet in our solar system. It is an ice giant planet, and it's a really fun one to look at as well. Let's see. So we had another request for NGC 253. NGC 253 is too low for us to be able to image right now. So let's look, another request for Betelgeuse. So Betelgeuse is in the constellation Orion, which is a winter constellation, and it hasn't quite risen for us. So unfortunately, we will not be able to look back at that right now. So we have, let's go to M11 real quick. We have another question from Bob F. What scope are we using right now? So right now we are using our plane wave telescope. It is a 14-inch plane wave, and the camera we are using is a Cam camera. So that is the actual imaging software that we are using currently right now. So while we grab that image of M11, let's see if there's any more questions. Let's see. Lots of requests, which is awesome. Okay. So there we go. There's M11. I believe this is an open cluster. which is pretty cool. So M11, this is an open cluster. I think it's the wild duck cluster. Could be wrong about that. But nonetheless, you can just see an amazing influx of stars on the image right now, which is just the amount of stars that you can see is just so amazing to look at. So we're looking pretty close to the center of our galaxy. And so this is a really wonderful open cluster to be able to look at. And really just the main thing about this one is just the sheer amount of stars that you can see. It looks like there has been glitter dusted all over the page. And it's just an amazing one to look at. So that was a really cool request. All right, let's see. So we have a lot of requests for Jupiter. So let's go do Jupiter. And we will be running out of time. So just again, if we can't get to your request tonight, no fear, we'll have some more of these interactive stargazing live streams that you guys can tune into. So if we don't get to it tonight, please keep your object in mind and we can try to get to it next week or some of the weeks after, but there's still plenty of opportunities to be able to participate in our interactive live streams. So we're taking a live image of Jupiter so we can start to see some of those stripes on Jupiter, which is pretty cool. Again, we're pretty low to the horizon. We're looking through a lot of atmosphere, so it's going to look a little bit fuzzy. We have a question. Can we see Titan, Jupiter's moon, and the methane ocean? So Titan's actually Saturn's moon, and our camera is not strong enough to be able to look at the methane ocean. So usually when we look at Saturn, we're focusing on the planet Saturn so that we can see its rings. And the moon is probably too small and too far away for us to really be able to zone in on those faint methane oceans. So we probably won't be able to get a really clear look of that tonight. So a question from Zach Davis, how many planets will we be able to see during the winter? So it kind of depends. It kind of depends on like what planets are up. So right now, Jupiter's up, Saturn is up, Uranus is up, Neptune is up, I believe Pluto is also up, and Mars. So really a good way, I don't know off the top of my head because they change with time and stuff like that. So a good way is to maybe grab a planisphere or just look online. But this year we do have quite a lot of planets up that will likely be up during the winter. But Jupiter and Saturn will be setting pretty soon. So that is just something to keep in mind. Let's see. Another question is how much planets have water? So the only planet that we're specifically sure of that has liquid water on its surface is Earth. But we have traces of water that we can see on Mars with the polar ice caps. And we're starting to come to more research that there might be some underground water beds there. But that research is still developing, and we're still learning a lot about Mars as we get over there with some of our new spacecraft and stuff like that. So we are very confident with Earth, obviously. Mars is probably the next bet for some more of that water type stuff. Other than that, Mercury doesn't really have any. We're pretty confident that Venus doesn't really have any either, in terms of the sense that you're probably asking. And our gas and ice giant planets really don't have any water in the normal sense either. So mostly terrestrial planets for that. Let's see. So we are at 8:28, so just a couple more minutes until we head into our Mars opposition live stream. So we'll do one more object to look at, and then I will hand it off to our guest speakers. So let's go ahead and go to the Pinwheel Galaxy if we can. We had that request a while ago, so let's go ahead and go to that. And that will be the last object for tonight. So again, I'm sorry if we couldn't grab your object that you requested. We had so many tonight, which is awesome, but just tune into our live stream next week and we'll try and get that object in for you guys. So we started off with a galaxy, we're ending with a galaxy. So the Pinwheel Galaxy, along with our Andromeda Galaxy and Milky Way Galaxy, form what we call the local group. So our local group of galaxies is the closest group of galaxies that we have in basically the universe. So M33, or the Pinwheel, is a really nice spiral galaxy to look at. So we can see at the center, it's a little bit brighter. We have that central bulge, but we can start to see those spiral arms coming off in this nice purple color really nicely as well. So the spiral arms are the areas where we're creating stars in this galaxy. So this is also a really nice one to look at. Compared to the Andromeda, which we kind of saw at a glancing angle, we're looking at this galaxy pretty well face on, so it's kind of fun to see these different perspectives of these galaxies. But it is just about 8:30, so I'm just going to say thank you guys so much for joining me with the interactive stargazing. Again, if we didn't get to your object, we'll have plenty of time in some of the upcoming live streams as well. So if you can, go ahead and subscribe to our little observatory channel. And if you're interested in seeing some of these objects with your own eyes, check the little observatory website, because we have some pretty awesome opportunities for private viewings going on. And if you're interested in doing that, it's an amazing thing to do, and we're always really excited to have more people come up to Lowell and experience these amazing things. So I'm going to go ahead and hand it off to our guest speaker, Bill Sheehan, for the night. So he's going to talk to you guys about the Mars opposition. And he has quite a lot of information. We'll be looking at Mars with the Clark telescope. So if you have any questions, keep them coming in the chat, but I'm going to go ahead and hand it off to him. So thanks so much, guys, for joining me tonight. Alrighty. Yes, here's Bill, so I'm going to go ahead and sign off.
All right, thank you very much, Claire. That was extremely informative. I learned that Albireo is not actually a true binary star tonight, and I hadn't really thought about the black hole inside of the M15 as well. So Klaus, can we put up that first image of the retrograde movements of Mars? I'm joined.
Give me just a moment, and I'll be happy to show you our slides.
So my name is Bill Sheehan. I'm joined tonight by Klaus Brasch and Kevin Schindler, and we're going to make this an evening of interest to both people that are dedicated to Lowell Observatory and also to all fans of the Red Planet. The special night is the night of Mars' opposition, where it is opposite to the sun in the sky, and therefore, because it's on the same side of its orbit as the Earth, it reaches its near minimum distance from us, about 39 million miles. And some of you have been tracking it only with the naked eye, but that in and of itself has been very rewarding because Mars is very bright and intensely red. One of the objects in the sky actually that is reddish, noticeably reddish. And this year is particularly so because, in contrast to other years like 2018, when it was marginally closer to us than it is this year, in 2018, Mars was enveloped in a vast cloud of dust, yellowish dust. And the telescope, like the Clark, which we're going to be looking through in a few moments, as soon as Mars clears the trees or whatever it is that obscures the horizon on Mars Hill. Even in that telescope, it appeared just as a bland orange. But now the air is very clear on Mars, and we're going to be able to see some of the surface features in their pristine glory. So that's the first bit to say. We're being joined by watchers around the world because this is a worldwide event, obviously, the opposition of Mars. And I'd like to say in particular hello to David Sellers and his family in Leeds, England, who are watching tonight. It's about 4:15 in the morning their time. So this opposition of Mars is also of interest, particularly to Lowell aficionados, because it was an almost identical opposition that occurred in the year 1894 that led to the founding of the Lowell Observatory. And Kevin Schindler, our Lowell historian, is going to shortly join us to talk a little bit about what led to this impassioned search for life on Mars that was the characteristic of the founder, Percival Lowell. I got a question. So anyway, it's a grand night for all people interested in the red planet. Let me start out with a little bit of Percival Lowell's beautiful prose. Lowell, of course, was a member of a very gifted family from New England. And among some of his relatives were several poets, including James Russell Lowell, Amy Lowell, who is known as an avant-garde poet who tried to push away from more traditional forms to imagism. And we'll be turning to Mars shortly through the refractor. Once in about every 15 years, a startling visitant makes his appearance upon our midnight skies. A great red star that rises at sunset through the haze about the eastern horizon, and then mounting higher with the deepening night, blazes forth against the dark background of space with a splendor that outshines Sirius and rivals the great Jupiter himself. Startling for its size, the stranger looks the more fateful for being a fiery red. Small wonder that by many folk it is taken for a portent. This star, of course, is the planet Mars, and the planet Mars was the particular interest of Lowell for the last 22 years of his life until his death. At this point, we want to take a quick look at Mars to see what we're looking at, what part of Mars we're looking at, and then we're going to bring Kevin. All right. Well, so I'm going to turn it over. Oh, we do have Mars now on the camera. You're seeing it. And the parts of Mars that are in view are different from those that were on view last week. Some of us may have joined us then. Celebrated feature on Mars, sort of a dark, wood-shaped area on the surface of Mars, and the first that was seen with a telescope with that view since Mars 24 hours 37. Since Mars rotates about 24 hours 37 minutes, which is a little bit slower rotation period than the Earth. The markings on Mars, if you view it every night at the same time, gradually slip backwards. So we sort of have a reverse of seeing the whole planet. So in about a week, 60 degrees of longitude has sort of slid beneath our eyes. And we're looking now at the Myrtirianum and Myrcerium.
Bill, it sounds like we're having trouble hearing you. And so, and Klaus, yeah, we had a problem with the camera, but Bill, we're having trouble with your sound. It's kind of coming.
Okay, can you hear me better now? Am I coming now?
I think so, yeah. But if it starts stuttering, I'll just talk for a little bit. Okay, and it looks like Bill's muted, so I'll just talk a little bit. And I'll say what a pleasure it is to be here tonight. This is part 2 of a 4-part Mars series we're doing here at Lowell Observatory this month. And it's really a great honor to have Bill Sheehan as our weekly guest. For those not familiar with Bill, he's a world-renowned expert on astronomy, a prolific writer. I can't remember how many books you've written now because it changes every week. But a couple dozen and adding quickly. And then Klaus Brosch, another eminent contributor to astronomy in northern Arizona, especially. Klaus is retired from the biology field, but has been a volunteer at Lowell Observatory for, I don't know, it probably seems like 50 years, but I think it's 12 to 15 or something like that. but an expert astrophotographer. And so to be able to share the stages that we're with you guys is really great. And we look forward to the next couple weeks. Every Tuesday night this month, we'll be talking about Mars. And so, and we'll see, Bill, if your sound comes back, but I'll just kind of yap. And if you cut in and I hear you, then I'll pay attention to you. So, you know, what a great thing with Mars opposition. You know, every 26 months or so, Mars approaches closely. And as Bill was talking about earlier, this year is kind of special for us, a little observatory, because this opposition is fairly similar to the one in 1894. And the one in 1894 is why we're here tonight, because it was that opposition that inspired Percival Lowell to go out to Arizona, set up an observatory, because he wanted to study Mars and particularly the possibility of intelligent life there. He had a lot of really interesting ideas, and that could be a whole nother program of why he thought there was life out there. It's not just these supposed linear markings on the planets that he saw, but it's a larger scale thing about evolution of planets that he was developing this idea. But what we thought we'd do a little bit here is, as we're going to get some more views of Mars as the night goes on, but just kind of set the stage a little bit of how we got here in the first place. And I think that's really interesting to talk a little bit about the early days of the observatory, especially why the observatory was set up in Arizona. Because Percival Lowell was, you know, from a wealthy family in Boston. At the age of 3, he remembers seeing a comet, Denante's comet of 1858. He said it was his earliest recollection. He had a lifelong interest in astronomy. When he was 15, his mother gave him a telescope. He set up on the roof of the family's home in Brookline, outside of Boston, and really got interested in space. But he was interested in a lot of things, really a Renaissance man. And so after graduating from Harvard in mathematics, working for the family business for years, he spent 10 years overseas in Korea and Japan, came back in the early 1890s, and you know, what are you going to do now? He was thinking to himself, he wanted to go into astronomy because of this idea that there might be life out there, and some of this evidence, supposed evidence, were these linear markings crisscrossing the Martian surface, supposedly. And Lowell got really interested in this, and so he decided to set up an observatory to study it, but realized doing it in the traditional places wasn't going to work. And I'm going to share my a PowerPoint here. So let me just get this up, and then I'll talk a little bit here. And I think that's sharing. Let me just, right. So, you know, if we go back to the late 1800s, observatories were typically located in large cities and universities on the East Coast. But as electric lighting was becoming prolific in the late 1800s, that was shining light up at the skies. And you had a lot of factories that spewed smoke out to block the sky. So between the smoke and these bright lights that, you know, made it easy to see the streets, but also blotted out the light from the sky, the natural light, Percival Lowell, on advice from astronomers from Harvard College Observatory, decided to send an expedition to Arizona. This was 18 years before Arizona was a state. There was no light pollution. There was no smoke pollution. There wasn't much anything going on here. It was the Wild West. There were 800 people in Flagstaff at the time. And so I sent Andrew Douglas, his name was, and here's a picture of him. Andrew Douglas had helped astronomers at Harvard College Observatory down in Peru, and thought this guy would be great to go out to Arizona Territory. We'll send him with this telescope you see here, a 6-inch refracting telescope it's called. And we still have this telescope on display today in our collection center. And notice this tripod with the stick here that he used to prop it up. So Douglas is gonna go out to Arizona. He's gonna take this telescope and several other devices for measuring temperature and humidity and other weather conditions, and set it up in different locations and go up at night, look at stars and planets, and look how good the air is, what we call seeing, the quality of the air. And he'll test different sites and look for the best site. And so he took all this stuff out there. Spring of 1894, he goes out to Arizona. And this is kind of the path he took. It started, the red indicates how he traveled on railroad, and then the blue is stagecoach. So he came into Arizona, again, Arizona Territory, the Southeast. He first came down here and went to Tombstone, and then he went up to Tucson, Tempe, Prescott, and then finally Flagstaff. And it was really, if you think about doing proper site testing, like Lowell Observatory did a century later to find a site for our Lowell Discovery Telescope, modern times we did testing over a couple of years because you want to see how the skies change over the seasons, for instance. But Percival Lowell was a man on a mission in a hurry, and he wanted to find this site quickly so he could start looking at Mars. And so he told Douglas, make it snappy. And so Douglas ended up just, in some cases, a few days or a few nights at each one of these locations. And we won't go into detail about all this, but I think a couple interesting points are some of the places he went to. In Tucson, he went to a place that was then called Sentinel Hill and another called Turtleback. And we know these today as A Mountain. The big University of Arizona A is painted on the top. And then Tumamoc Hill is a great archaeological site. So these are sites that we're familiar with today, but those are places that Douglas went to test the skies in Tucson. And he not only looked at the weather conditions and the telescope viewing conditions, but also reported on things like the vermin that were in the area, spiders and critters. At one point he wrote that they have nice hotels for the lady folk. And so he looked at all the different factors that would be important for setting an observatory. This is a great site. If you're familiar with Central Arizona, you might recognize this. This is a site he went to in Tempe. And had he chosen this as a site for the observatory, I'm not sure if we would be here today, because this is what it looks like today. This is Tempe Butte, right in the middle of the university, or Arizona State University and football stadium. And that's their A Mountain. That's one of the sites he tested. So thankfully, they didn't choose that as a site for the observatory. After they left Tempe, he was going to go to Prescott. And Prescott was pretty sketchy. There was no Interstate 17 to go north and then cut across on another road. There was just what was called the Black Canyon Highway, which was really a perilous road. But Douglas had another problem. That telescope was about 6 feet long, and then there's a tripod, and each one of those components went into a long box that were roughly 6 feet long. And when he tried to load them onto the stagecoach in Tempe to take them over to Prescott, the stagecoach driver refused to take them because he, as he described, this Eastern dandy was trying to take these two coffins on the stagecoach, and he had no interest in taking these coffins. And Douglas tried to explain their scientific equipment. He didn't want to have anything to do with that. So Douglas had to put the equipment on a train, and it had to go over to El Paso, up north to Albuquerque, over to Ash Fork, and down to Prescott. And it got there about the same time as his stagecoach ride because it was such a rough trip over to Prescott. But he finally ended up in Flagstaff. And this is a really lousy picture. But the reason it's lousy is because this was one of Andrew Douglas's pictures he took in 1894. And it's interesting, I think, that one of the things they were trying to get away from was the smoke from factories. And yet, if we look in the lower right, that's the lumber mill that the Reardon brothers ran, the Arizona Lumber and Timber Company. And they tested a site right above the smokestack there. And that's the site they chose to set up the observatory, even though the smokestack was there. This is what this looks like today. Site 11 was right around somewhere in this area. And this is what that hillside looks like today. And there's a days in there. And there's nothing right on this site because after he tested it, by this time, Percival Lowell was really in a hurry to set up the observatory. He wanted to study Mars. Just like we want to look at Mars tonight, Percival Lowell was in a hurry to see it. And so once Andrew Douglas found the site, they then moved, not on the edge of the mesa here, but they moved about a half mile north. And because that side of the hill was more gradual, they could build a road up there easier. And that's where they set up the observatory. And the first telescope dome, this is it. It was a prefabricated dome from back east from Harvard. They set it up, borrowed a couple telescopes for that first season. And the weather was pretty bad. And it was good enough to get started, but it was unclear if the observatory would actually stay around because of the weather. But within a year, Percival Lowell ordered another telescope. And this dome no longer sits here. But if you look at the trees on the side, on the left side, the right side, and this one hanging down, this dome was taken away. And then this one was put up. And you can see it's right on the same spot that we're seeing Mars through as we go on with the program. The dome has changed some because it originally had canvas on the top. The canvas was designed to help equalize the temperature from the outside to the inside. That worked great in Mexico, but in Flagstaff at one point we had a lot of snow. And so they had to stabilize the roof with wood and metal. But it's the same dome today that was there back then. So that's what got the observatory started. It started because of Percival Lowell and his interest in Mars. And, Mars and Lowell Observatory, they're very closely entwined. Whenever you see any scientific announcement about, potential life, not just on Mars, but in the solar system, or water on Mars or in the solar system, Percival Lowell's name is always brought up because of these ideas he had. And the ideas of life he had, of this intelligent life, simply do not exist there. We know we've sent spacecraft there. Nothing's like that there, but it's certainly still possible that at one time there could have been some sort of microscopic life forms underneath the surface, for instance. But nothing like what Percival Lowell thought. And yet, even though we look back and can even chuckle at some of his ideas as seeming kind of outlandish, he set the stage for this idea that there's life out there and that we should search for it. And then we should look up at the sky and wonder about our place in the universe. And that's really a legacy that he left that resulted in the discovery of Pluto in Lowell Observatory in 1930, the first evidence of the expanding universe that Claire mentioned earlier. 100,000 visitors the last couple of years to the observatory because of Percival Lowell. And so he left quite a legacy, and it all started with his interest in Mars. And so as we celebrate Mars tonight, and this very special opposition I think it's kind of fun to go back and just relive a little bit about why we're here and Percival Lowell's legacy. So I'm going to stop sharing this. I'm hoping that Bill, you're...
Are you able to hear me now?
Yes. Yeah, I can hear you now.
Good. Excellent, Kevin. Right. I mean, if we had a time machine and we went back to 1894, Mars would be almost exactly paralleling tonight what Percival Lowell would have seen on October the 13th of that year. So it really is like having a time machine at our disposal and going back. And one can put oneself in his position. I mean, some of the, am I still coming through?
It's
some of the
really
things
kind
that
of
are
shaky.
ironic is that the Lowell family achieved all of its wealth through textile manufacture back in New England. Lowell and Lawrence, Massachusetts were the cities where they built their textile mills. They generated power through through canals. They dammed up a river to create canals that turned wheels that then drove the various machines to make the textiles. And so the East really was polluted in large part to serve the Lowell family's fortune, and then eventually skies that you can find there, as those in Arizona. So why don't we take a look? There are a few questions here that have come in. One person asked where they should go to view Mars outside, and Mars is now rising in the east. So if you turn and look towards the east, you can't miss it, assuming that you're not looking through a brick wall or something like that. And it's very bright, very red, and very obvious and evocative. We'll turn to the image. I guess that's in right now. And what do we see in that image of Mars? Well, it's separated into dark and light areas. And the old time observers like Percival Lowell thought that these were possibly seas and continents. Lowell, after his first year of observing in Flagstaff, decided that water couldn't exist on Mars, and instead these must be tracts of vegetation. And he believed over time that he was seeing the growth of vegetation as it got bluer, darker, these areas, and then the fading away of it were. And we now know that all of those changes were illusory. Essentially what changes on Mars is the amount of dust covering on sort of large basalt plateaus. So the basalt is dark, and this fine feathering of dust falls onto these dark areas blown by the winds and causes them to fade out a bit. And this kind of goes on from one opposition to the next. We see different areas covered a little bit, and then the regular seasonal winds blow the dust away, so that these are always shifting over time, although the main outlines remain the same. So we're seeing a couple of areas that were named seas, actually. Mare Serenum, the Sea of Sirens, is one, and Mare Tyrrhenum, the Tyrrhenian Sea, is the other in this image. And I'm not sure if Klaus can get us a map up to show kind of the orientation of what these features are.
Let me give it a try.
And perhaps while you're doing that, you can talk a little bit about like you mentioned before, Bill, about the kind of waviness of Mars and why it's moving around like that.
Oh, right. So a lot of people that look at drawings or photographs of Mars, particularly drawings, because back in Percival Lowell's day, the way that a planet was studied was essentially to put your eye to the eyepiece, sit on a chair, or in some cases an observing ladder, with a sketch pad, and attempt to memorize what you see in the telescope to paper. What we're looking for is that map, the big map.
Yeah, there you go.
There we are.
What we're seeing right now is this region right here. That's visible in the Clark, except it is inverted in this telescope as opposed to what we see here. So just imagine this picture upside down right here. That's what we're seeing.
Yeah, so this is the
And we're
furthest
seeing
major that
parts
we had a
of
good.
this area.
Yeah, the Mare Tyrrhenum here, and then the Sea of Sirens over here, or Mare
Right.
Serenum.
And we just had a question about the volcanoes. If there's more than one volcano, maybe you could point out the.
There's several volcanoes right over here. These are called field volcanoes, and if you've heard about Mount Olympus on Mars, which is the largest volcano in the solar system, it's no longer active, although it's, who knows whether they are totally dormant. We often call them dormant, but we never really know. And here are 3 additional volcanoes as well.
And
So Mars, yes.
I might point out that Olympus Mons is about the size of Arizona.
That's a good point as well, right here. So if you were to take Arizona and put it over here, that's how big it would be. And it reaches.
We got another question from our good friend David Barron, another eminent author. I mean,
Hello.
the video image from the Clark telescope is north at the top or bottom?
In the Clark telescope, the way it's oriented is actually with north at the top and south at the bottom.
Correct.
They must be using inverting eyepiece because
Yeah.
normally a telescope turns things upside down and it gets a little bit confusing, but we're actually looking at a view with north at the top. I'm not sure if people can make out on that image a tiny little white patch at the bottom of the image, which is the south polar cap. And that is quite large in scope during the southern hemisphere winter, and then it melts quickly away. And the reason it melts so fast is that it's actually a mixture of carbon dioxide, frozen carbon dioxide, and water ice. And the carbon dioxide essentially just fizzes away into space. It's through a process called sublimation. So it quickly disappears, goes into the atmosphere. And the only thing that's left then is this small, what's called a residual cap, a remnant of the polar cap, which is water ice. So what we're seeing now, if you can see it on that image, at the bottom is just a tiny little patch of white. And the northern hemisphere then is meanwhile going into winter, autumn and winter, and it's forming a new cap and often covered with cloud. And this would be a good place, Klaus, to bring up those images of Hellas that show it.
Right. Well, I'm in the process of doing that. Here's a picture of taken by the Hubble Space Telescope, and here you see the southern polar cap right now. This is the area here called Hellas that was first observed by Christian Huygens in the 1600s. Here's a picture of it taken by E.C. Schleifer, one of Lowell Observatory's most famous observers. Here's what it looked like to me a few years ago in a sketch, as I was observing with a smaller telescope. And then this is what Hellas is actually like in these. Here's a beautiful picture taken by an amateur astronomer, Leo Ayers, showing Hellas right there. And we now know from satellites that have been circling Mars that this is a huge impact basin, this bright area here. And in addition, if you look at the Hellas area at different times, for example, during 2014, you can see it was completely white in these various images taken at that time. And the whiteness is actually due to frost deposits and cloud deposits because it was then winter in that part of Mars. So this gives you some idea of the kinds of changes that Bill was alluding to before. And in the past, of course, when you were relying entirely on Earth-based observations, people didn't really know what to make of it. But the idea then, of course, was that possibly there's vegetation, there's water that melts and that feeds the vegetation and so on. Well, we know now that none of that is in fact true.
We have a couple of questions coming in that I'll direct here. Maybe Klaus, you can take the first one since you're talking about some of these features, the percentage of water versus dry ice in the ice caps.
Right. Basically the two things to keep in mind. The ice caps are mostly due to condensed carbon dioxide, which is the main gas in the atmosphere. But underneath all that is also a deposit of frozen ice. We know that now because a few years ago, NASA sent a probe to the southern polar region that actually dug into the ground and discovered ice, blocks of ice, which very quickly, water ice, which very quickly sublimated. So we know that Mars was once, as I think Bill and Kevin said before, in the past, probably several billion years ago, Mars had a denser atmosphere and at that time had liquid water in all probability. Much of that atmosphere has dissipated so that water can no longer stay liquid on the surface, but that doesn't preclude it from being in ice form or even liquid form deep inside the surface of Mars. So that's an exciting possibility for future exploration.
And I'm not sure, your sound was still a little choppy, but we'll try. I'm just going to keep doing these questions until we know that your sound is good. But there was a question about the concept of the canals and how that originated. And I know we don't have 8 hours to talk right now.
Right.
You can recap that if the sound comes through.
Am I coming through now?
Yeah, I can.
Yes.
Okay, right now.
Okay, good. I'll speak louder as well. The canals really ties in with a couple issues. One is to finish up what I was talking about earlier. Why is Mars blurry? Well, we're essentially viewing Mars through an ocean of air that is streaming overhead. So as the air passes overhead, Mars is continually in tremor. And so though we kind of think of drawing a planet through a telescope as maybe being like doing a sketch of a still life, like a vase with flowers, the reality is it's more like trying to capture images as you're traveling at high speed on an express train or watching a television show or trying to figure out at the racetrack whether the horses' feet all leave the ground at the same time. So the eye is a wonderful instrument, but it's in terms of like its imaging capability, it's very slow. So observers looking through this ocean of air would see a moment of very clear view, but then it would quickly be obliterated. And then the eye and the brain would try to put together what it actually saw during that, what Percival Lowell called revelation peak. And the eye and the brain did not evolve to look at planetary surfaces. They do the best they can, but basically what they do is they make a sort of a schematic diagram of what's there. And that tended to be this tessellated surface of lines. And so if you look at all of these drawing or these photographs, you don't see any canals, but you do see sort of faint darkish patches. And those were the things that the eye of somebody like Percival Lowell strung together into these intricate maps of canals. So they were essentially an illusion, and yet a very evocative one, because as Lowell said, they were fine lines and little gossamer filaments only, but lines to draw the mind across the millions of miles of intervening void. So yeah, the canals are certainly a lustrous part of Martian history.
Bill, your sound seems pretty good. Maybe if you can try to talk a little bit louder still.
Sure.
But
Sure.
I'll let you run with this again, but I just wanted to point out to everybody that Bill Sheehan is a retired psychiatrist, and so has a very important insight on a lot of these matters of what the canals were and what they were seeing. I mean, this is all part of his career as a psychiatrist, combining that with an interest in astronomy. So it's really special to have you here tonight to be able to talk about this.
Well, thank you, Kevin. But the other thing about the canals is that, and Klaus and I talked a little bit about that before in our previous session, canals were really all the rage in the 19th century. I mean, they were seen as some of the most advanced technological developments of the Western world. And in particular, there was the Erie Canal, the Suez Canal, later the Panama Canal. And so it fit very nicely with this idea that Mars was an older planet than the Earth, that it had lost most of its water, and that if there were intelligent beings there, as Percival Lowell believed, in order to stave off their ultimate extinction, what they would need to do is create these vast engineering works to carry what little water there was from the melting polar caps to these vast desert regions. And the evidence of that were these lines that were the presumed tracts of vegetation along the canal banks, which inspired a whole lot of science fiction. And then also these dark areas, which Lowell thought were indeed tracts of vegetation feeding the hungry Martians and thirsty Martians. So it was a wonderful image for the 19th century. And indeed, in some ways, it was prophetic, because Phoenix, Kevin mentioned Douglas's passage through there on the way to Flagstaff, would be uninhabitable, but one for the damming of the Salt River and the canals which allow water to supply the population of Phoenix, and the other is air conditioning. Phoenix is a little bit like an uninhabitable place, but temporarily inhabitable city. Flagstaff may have the same fate in a few years.
Hey, Bill, if you're able to see the questions coming in, it looks like there are a few more.
Right. Why is Mars red? Well, Mars is red for the same reason that rust is red and blood is red. Essentially, Mars is a rusted planet. Oxygen is combined with iron and rock, just as we see, for instance, in the Painted Desert near Flagstaff, and very fine dust on Mars. It's very, very tiny, and the basalt rock always iron in it. And so as this stuff gets blown around Mars, it turns the whole planet into this beautiful reddish color. So yeah, that's the reason that Mars is red. And so the ancients who thought, named it after the god of war, because it looked.
And Bill, we're losing you again. So maybe we'll have Klaus talk a little bit and answer some of these questions.
I can't see the questions,
Yes,
unfortunately. If you could read them out for me.
Okay. What's the highest concentration of methane measured on Mars, and where is it?
Well, the question of methane on Mars is one that's rather questionable, shall we say, because there's a big discussion now as to whether it is biological origin, because a lot of microbes on Earth will exhale as part of their metabolism methane, so it's a surefire signal there. But Mars does not have very much, and I can't quote you any exact numbers because it only happens sporadically. Another potential source of methane is volcanism. And yet Mars does not have active volcanoes as far as we know. So if there is any kind of activity below the surface, which once in a while will belch out some methane, that's another possibility. I think on the one hand, people would hope that it is biological because as we send future probes to Mars to dig beneath the soil and other things, looking for hopefully microbes that are still existing there under the harsh conditions of Mars today, perhaps they will, among them, release methane as a signal, but we really have no idea. And the concentration is incredibly low at best, and it's only been detected because we have such very, very sensitive spectrographs on our the various satellites that are circling Mars, and you can also detect it from Earth, but it's not a lot. So I know it's a roundabout answer, but that's the best we can do at this point.
Sure. And we'll see, Bill. Bill, are you able to come back on? We can see. Oh, you're muted.
I seem to be having some problems with an unstable internet connection, so I'll keep trying the best I can. But yeah, please feel free to cut me off if I start to get garbled or whatever.
Yeah, it's not personal.
No. No one is well served with a bad internet connection. So do we have any other questions, or should we?
There's a question about the atmosphere and what it's made of. You guys have touched on that a little bit.
Yeah, that's an interesting question. For a long
I think we better turn it back
time,
to Klaus,
astronomers, including Percival Lowell, overestimated how thick the atmosphere of Mars was. I've probably lost you again. Anyway, they overestimated because they didn't realize how much dust there was in the atmosphere, so they thought it was a lot thicker than it really is. And they long assumed that it probably contained constituents similar to the Earth, such as oxygen, water vapor, nitrogen. But we now know that it's mostly carbon dioxide. It's like 95% carbon dioxide with just trace constituents of water vapor and other things, and no oxygen at all, or minimal amounts of oxygen. So essentially, it's a very different kind of an atmosphere than we'd hoped, but that's what it's made of.
Bill, I feel like we're watching one of those old Godzilla movies where the sound aren't quite matching. Klaus, maybe you can take over, and we don't have any other questions right now, so if there's some other things you want to talk about.
Yeah, what I'd like to tell people as we're watching Mars and we're seeing the real thing through a classic telescope. I mean, this is quite a thrill, especially since it now is essentially a kind of a centenary or a little bit more, and how far we've come in our understanding of Mars, from basically the idea that was very prevalent at the time that Mars was indeed inhabited by advanced intelligence that were building canals to siphon water from the polar caps to the equator so that they could then survive. Many of you, I'm sure, remember the famous story by H.G. Wells, English writer who wrote War of the Worlds. And then our own Wells, not H.G., but the famous actor, they did a radio play in the 1930s, I believe, or 40s, that in fact they pretended to be reporters on the scene where a Martian craft had landed somewhere in New Jersey. And people believed it, even as recently as that. And if you ever get a chance to view some of the old movies, the original War of the Worlds movies was made in 1953 in lurid Technicolor. And I remember being a kid and scared witless when I watched it. But it's a lot of fun. And then a remake was made a few years ago, I believe in 2005, which is also very good. So the idea that there is life on Mars has been with us for a very long time.
Hey, Klaus, that's a good mention, because Bill and I were just talking earlier today about, this is part 2 of a 4-part Mars series for the month. And toward the end of the month, as we approach Halloween, it might be fun on our last Mars presentation to talk about some of the sci-fi and War of the Worlds, which premiered on Halloween night.
That's right.
Tied in with, you were talking about the ideas of life on Mars, one of the things that would be important is the temperature. And we had a question from somebody about the temperatures on Mars. So maybe you could touch on that.
Right. Well, the temperature on Mars is, for the most part, incredibly cold. when the only time that it reaches anything approaching something we could tolerate is at the equator in the summer, when it actually, a Martian summer, in either one of the hemispheres close there. And the only thing there would be that it was somewhat above the freezing point of water. At night or at other times, it gets many, many hundreds of degrees colder. And so Mars really is a frozen world for most of its existence recently. The reason that is so is because its atmosphere is not thick enough to trap enough sunlight so that it can heat things up. As you know, sunlight comes through our own atmosphere, and most of it is reflected back out, but some of it is trapped, and that keeps our temperature as it is for the most part. But Mars simply does not have a thick enough atmosphere for that to be the case anymore. And so that's in contrast, if we look at our sister planet in the other direction, closer to the sun, Venus is a runaway hothouse, literally, because it has an incredibly dense atmosphere, about 90 times as dense as our own, and it consists mostly of carbon dioxide, which is, of course, a greenhouse gas. So on Venus, the heat is trapped, and the surface temperature on Venus is several hundred degrees. And to make the place even more pleasant, the atmosphere is quite rich in sulfuric acid, which is something that most of us couldn't tolerate for any length of time. So it's really ironic that we kind of have Mars, and this is what actually Percival Lowell thought was happening, that Venus was a very young world in terms of possibility of life, that we were at the prime on Earth, and that Mars was dying in terms of life, because he had this concept of the evolution of planets going through certain cycles and sequences with respect to life and how comfortable or not it would be. So that's kind of the atmosphere story of Mars. The other thing I'd like to mention as we come to the question of possibility of life on Mars is that you may have heard that a Martian meteorite was discovered in Antarctica many years ago, and was analyzed by scientists at NASA. And it did contain compounds that might have been breakdown of some organic compounds. And so the idea that Mars was potentially had microbes on it in the past that then sort of became fossilized and became part of this meteorite, which was then launched into space because something hit Mars to essentially send this meteor flying into space. And eventually it landed on Earth and was analyzed. And of course, there's nothing live on it, but there are some residues of organic material. And that gives people hope that perhaps, again, there might be at least fossil, if not real existing life deep beneath the surface on Mars.
Well, it looks like 7 minutes left. So maybe we can, if there are any other questions, let's have those, send those in now. But there are a couple of questions for both of you. Or one question, Jason Chen wants to know, what would you like to know most about Mars? You know so much about the past. There's a lot of, what would you like to know going forward?
Well, I'll let Bill handle that. Bill, are you back with us? Well, can you hear me now?
Yes.
Good, good. Well, what I would like to know is whether human beings survive on this planet long enough to be able to reach and land on Mars before they go extinct.
Who, the Martians or us?
Us. Because, if we don't survive on this planet Obviously kind of a lot.
Well,
How about you, Klaus?
well, as a biologist,
Back
and
to the Godzilla model.
no, not the Godzilla model. No, that's Kevin's model. That's not mine. No, as a biologist, I would be tickled pink if we did, in fact, find microbial life or even other life beneath the surface of Mars when we send our probes there in future. And the interesting thing would be is that if there are Martians, if there are microbes or other smaller creatures on Mars, then the question is how like or unlike are they compared to Earth-like? You know, are they based like we are, needing water, made of proteins and made of DNA, or are they totally different kinds of chemistry? Either way, the answer would be very, very interesting. Because if they are the same as life on Earth is, then one could argue that that's probably a widespread life. That's how we'll find life everywhere, on other planets perhaps, or around exoplanets. On the other hand, if the chemistry, the biochemistry of Martian creatures is very different, then that raises another interesting dilemma for biologists and other scientists to say to ourselves, how did that happen? How did it originate separately? And how many times has that happened elsewhere? Meaning essentially, maybe there's really weird alien life somewhere that we have no idea about, nor do we have any idea what it might look like. So again, there's lots and lots of interesting stuff that we can ask and we might be able to answer perhaps in the next 10 or 15 years.
And you know, another possible angle, if they are similar, is could life on Earth have originated on Mars or elsewhere in the, you know, the getting into the panspermia model of, so maybe you could talk about that as our resident biology expert.
Well, panspermia, I'm sure many of you have heard about it. That comes from the Greek word meaning life everywhere. And fundamentally, it was actually postulated by the ancient Greeks that life is in fact ubiquitous everywhere in the universe, and that it kind of travels like spores or like seeds that fly through space and land on suitable planets, and then you have life kind of thing. So we tend to think that life on Earth as we know it originated on Earth very early on, some 3.5 to almost 4 billion years ago, when the Earth was finally cool enough to have life on it. It's possible that's what happened, and that's why if we find Earth-like life on Mars, one can then argue that one planet contaminated the other through stuff flying from one to the other, which we know happens because we have found Martian meteorites here on Earth, and we're pretty sure that Earth-like meteorites probably landed on Mars as well. So that would be the panspermia idea. And who knows how that might go and how far that might go. So that's my little bit of science, almost fiction.
Well, we have 2 minutes, so maybe, Bill, if we can get your sound for 2 minutes, if you want to give us some closing thoughts.
Well, I think, am I coming through at this point?
So far, so good.
Anyway, I think that, Mars has always been the most compelling of all the planets because of its similarities and as we're increasingly finding out, its differences from the Earth. So it's really shed a great deal of light on our planet, its evolution, the place perhaps of human beings in the universe. So I think that Mars will continue to be our prime objective as we move forward with the bevy of space missions. We currently have some orbiters and at least one still working rover on Mars. We have Perseverance, another rover, and a couple other spacecrafts that other countries are mounting that will be arriving in the near future. And the hope with at least the Perseverance rover is that they'll be able to get samples of material for return to the Earth on a later and evaluate what the possibility is of finding microorganisms there. And if we do discover those, as Klaus was saying, that will in and of itself be revolutionary and a major stepping point for human beings and their exploration of the universe.
Well, it looks like our time is up. So we kind of did a little role reversal here, Bill, because of the internet.
Yeah, so I apologize for that. I kept getting unstable internet, which is really kind of unnerving. I apologize, but as Klaus can certainly testify, probably Kevin too, I'm kind of a little bit of all thumbs when it comes to technology.
Hey, I'm not much better.
Well, I'd like to thank everybody for joining us tonight. This is part 2 of our 4-part Mars series this month. We'll be back next Tuesday night and then the Tuesday after that. And as we mentioned, that last Tuesday, we'll probably talk a little bit about, because we're approaching Halloween, talk about Mars and Halloween and War of the Worlds, and maybe a little bit about, Percival Lowell's impact, not just on future science, but also things like science fiction. So thanks everybody for joining us tonight. I'm speaking for Bill Sheehan as the host, but on behalf of him and Klaus Brosch and our entire Low Observatory team, thanks for joining us tonight.
And hopefully we'll have a reappearance of Godzilla. Well, I mean.